Number 3, we're asked to sketch graphs of these surfaces, and you'll see that these are all quadric surfaces. So these are ones that we're just supposed to recognize the equation and therefore know what the graph is. So this first one, remember this is a hyperbolic paraboloid. So what I get here is if I imagine the x being 0, I get z equal y squared. Well, that's a parabola going along the y-axis up in the z direction. And then I imagine the y squared being 0, then that's going to be z equal minus x squared, which comes down like this. So it creates the bottom of the saddle, which we know that's what the hyperbolic paraboloid is. So it's a saddle going along that direction. All right, let's move over to this one. This has one minus sign. We know that's a hyperboloid of one sheet. And since the z is the one with the minus sign, it's going to be going in the z direction. And so it's going to be opening at 2 and down here at minus 2. And basically you get these sort of look like the elliptic paraboloids, but they're not. It's some sort of bowl shape going in that direction. All right, and then B, y equals z squared plus x squared. That is an elliptic paraboloid, and it's going to be opening in the y direction. So it's just going to go like this. There's really nothing to label on this one, since it's hard to draw the nice dimensions here, so this would be fine just having it open in the y direction. This time we've got x squared minus y squared. I think that's a typo, so I'll scratch it out. X squared minus y squared minus z squared. So this has two minuses, so we know that's a hyperboloid of two sheets, and it's going to be going in the x direction because the x is the one that doesn't have a minus sign here. And so I'll draw basically a hyperbola going along the x direction, and then you make your hyperboloid of one sheet by doing that. And there is something to label here. This is going to be 1, and it's crossing the y-axis over here at 1 because these are both divided by 1. Okay, part C. This is an ellipsoid because we got all plus signs here. So we'll do the ellipsoid. And this ellipsoid is going to cross at 1, and back here at minus 1. It's going to cross at 2, back here at minus 2, and then up here at 3, and down here at minus 3. So you kind of connect the dots in a reasonable way. It's to come down around here and up the top. So something like that. There's your ellipsoid. And then this last one, this would be a cone, and since the y squared is over here, it's going to be cone opening in the y direction. So let me draw that. The y direction is this way. You just basically draw two intersecting lines, and then you make your cone. Nothing to label on that one. All right, number 4. We've got a couple of graphs that we're asked to complete the square and then identify the graph or sketch the graph. Well, so this first one, to complete the square, I need to get the y over here with the y. The x squared and the z squared don't have anything to pair with them, so those would just stay the same. But I need to add something. I need to add something here. Well, we know what we add is minus 2. You take that coefficient, take half of it, and square it. That's minus 1 squared. You need to add 1 to both sides. And then once I do that, this is a perfect square. This is going to be x squared plus y minus 1 squared plus z squared equal 1. So this is a sphere. It's been shifted 1 unit down the y-axis with a radius of 1. So if I draw that, 1 unit down the y-axis with a radius of 1. So if it has a radius of 1, it's going to cross through 2. There's its center at 1, and then you try to draw your best sphere. So it's going to come around, go around that way. I didn't do a real good job on this one. Anyway, it's supposed to look spherical. The second one, when I look at it, I can see that the z is the only thing that's going to have to be, the square is going to be completed on that. This is just x squared and y squared. So if I complete the square on z, again, I take the minus 4, take half of it and square it. That's going to be 4. So I have z squared minus 4z plus 4 equals x squared plus y squared minus 4, and then I'll add that same 4. I have to add it to both sides. Cancel out over here, but this factor now is z minus 2 squared and over here I get x squared plus y squared. That's a cone that's been shifted 2 units up in the z direction. So it's going to be a cone. Instead of having the cone starting here, it's going to be here at 2. And that's where the cone, then you draw your sort of intersecting lines. And your cone comes around like that. Again, it is staying on the z-axis, just been shifted up 2 units.